Today we're going to learn about calculating noon sun angles. Why are noon sun angles important? It has to do with the season. If you are standing at the equator, your noon sun angle is always going to be pretty much the same, and you'll have 12 hours of sunlight and 12 hours of nighttime pretty much all year. What about the rest of the year with the rest of us? Well, this helps us to figure out how we determine what season it is and what effect the insolation properties are because of that shift.
More.
More?
The students want more.
All right.
We love it.
We love it. More. All right. So, I'm not at the equator. I'm at San Diego. 32 degrees north. The sun can only move as far as 23 degrees north or south. This area defines the tropics, and this swing back and forth is our annual swing of seasons. So, if the sun is at 23 degrees, what time of the year is it? Well, it's summer, of course. How did I figure that out? Well, oh shoot, I picked the wrong date.
It's okay.
All right.
Keep going. You're doing great. This is.
Right.
I love this.
All right, so I picked the wrong date. Let's start again.
What's wrong with summer?
Well, because I did the equation for spring, or for fall.
Doesn't matter.
For summer. Well, we
You can do. You can go back to fall in a second.
All right,
Still rolling.
still rolling. All right, so let's say that it's October 10th. October 10th. It's autumn. So the sun is going to be way the heck down here. What does that mean? That means that the solar energy is going to get spread in a much longer pattern than this straight up and down area, or even over here. So, if this diffusion of energy is October, how much sunlight do you think each area is getting? Well, it's going to be less than here in the tropics, so the temperature will be cooler. This is why we want to know about the noon sun angle. So how do we figure this out?
Rolling.
Okay, so the next section of the problem has to do with how to use an analemma. The analemma shows the path of the sun for the entire year. How do you figure out where the sun is? That's your subsolar point, anywhere on this. It's very easy. We're looking for October 10th. So, here's October, and if you look along the edges here, you'll see all kinds of little tick marks on your analemma that you have at home. Now, you simply follow this over to the center. If you look at the center, you will see that there's little numbers here and this equator. This tells you whether you're north of the equator or south of the equator. So, we are south of the equator, and we're down here, and I made this one particularly easy. We're exactly at 10. So, that's the degrees that you will use for your subsolar point. Wasn't that simple? It's done. No, I'm done.
No. We want more. What are we going to do with that information? How are we going to tell from our 10 degrees?
Oh, well, I did the problem before.
Oh, okay. All right, cool. Now I know what an analemma is.
If the subsolar point is north of the equator and your location is north of the equator, you subtract. However, if your location is north of the equator and the subsolar point is south of the equator, you add, because you are looking at this distance. So how do we get the solar angle? So you make a drawing of your Earth, and then you go to your analemma. So you make a drawing of your location, the equator, and your subsolar point. This will enable you to decide whether the degrees are going to be added or subtracted. It's
easy for you to say.
It's a simple calculation to figure out what the noon sun.
One more time, just start over.
It's a simple calculation to figure out what your noon sun angle is at this point. How do we do that? Well, first, the sun can never be more than directly overhead. Second, you are always going to subtract from that point. So, we take our location, we add our subsolar point. This will give us our noon sun angle. It's that easy.
Dance.
So, this is the Earth, and we are doing what I call my seasonal dance. Pretend that my hips are the sun. What season is it right now in San Diego?
Summer.
Very good. You'll notice the sun is going to be shining up here at the North Pole all day and all night.
But what about at the South Pole?
It's going to be dark. Look at the angle of the sun. Does it ever reach the South Pole? There's no sunlight down there. Let's change seasons.
And dance away.
So now for the other part of the dance. What time of the year is it now in San Diego?
Winter.
Very good. So is there ever any sunlight hitting the North Pole? Pretty dark up there, huh? But what's going on down here in the south? This will come into play more when we study more about weather and how things work. But remember this for future reference.